construction admin building, just like City College at Redwood Road. To start with, we're going to walk around some of the mechanical rooms in the different areas and show different locations and briefly talk about sequences and functions and identify different sensors and whatnot. To start with, we're in the mechanical room down in the hot water system looking at the heat exchanger. We're going to start in the back of the room and kind of go forward. This valve right here, obviously, you guys know, is your isolation valve. This is tied to two different things. It's tied to that emergency switch on the wall right there, so if there's emergency, shut that. It fails closed, the will screen closed. And also, if you disable the system, that steam valve will also, software you can close it as well as you need. After there, we go through the different heat exchangers. If I remember right, this is 1 and this is 2, I believe. So you have your steam valve modulating right here. These steam valves right here are modulating to maintain a supply temperature in your sensor, your common sensor, which is right up here. You can see those up there. It's right here. The way the heat exchangers work is we try to maintain a certain hot water temperature which resets off outside air, and so as needed, generally you only run one heat exchanger. As needed, if you're not able to handle the load, if our valve's at 100% or our PID's at 100%, we will call for the lag heat exchanger to run. Generally, you'll only be running one, but on a huge load, you might need that second during the PID. Yes, exactly.
At 160, it's probably your top 20.
I believe it's 160 or 160. Yeah, I think it's 160.
160 would be your.
I think 120. Yeah,
that's just a low point. And then the low point is like 100 and like 120.
Yeah. Which is kind of what we're running at now. So as we go through this, you do have some sensors here, which are your leading temperature sensors. They're used for monitoring, get an idea of what it is, but they're not a controlling sensor. Your key sensor is the one up here on this pipe. As we follow this pipe down, can you see it okay?
Yeah.
Okay. And even if we come over to this side, we might be able to see it a little bit easier. As we keep going through, a couple other things that are real important. This right here, this device, the differential pressure switch. What we're doing with that is it acts as a flow switch. So if we don't have differential pressure in that line, which means we don't have any flow, we disable the system from running. It's just an extra safety prevention.
So the valve shut?
Yep, exactly. The valve is shut down.
If I'm not mistaken, on the heat exchanger are the only valves that will shut. So on the AA2, they won't be open.
Out of build position, you're absolutely right. The AC valves will fail open. These ones will fail closed to a speeding. We don't want to, On a shutdown, on a low flow, these valves will shut, but your pumps will continue to kind of low. And all those other valves will remain independent of that. As we keep going down this pipe, you'll see another sensor here in a bigger gray handy box there. That is an on-o'clock sensor, which is tied to your heat sensor right here. See it up there? Okay.
Yeah, so like an offer. That's like offer stat.
This one right here is actually like an aquastat.
So it might be
Yep, that's a good point. What that is for, that's a high temperature alarm. And that's set at, I believe, 180 or 200, no, it's set at 200 degrees.
Oh, okay.
And what that's for is if our valve went wild or somebody did an override or something like that, if that gets above 180 degrees, or 200 degrees, it's a manual reset. It'll shut down, it'll deactivate a relay, shut all the valves in the system, and issue you guys an alarm. That is a manual reset. So if your system won't run, you need to make sure your high temperature alarm has not tripped. Alright, and that's just a well inside the pipe with a manual reset. As we keep going down the system, on the other side of this wall here is your flow meter. That's tied to your ECU, just a hot water flow meter. And coming back, right here, your return sensor. for the BTU meter right there.
Okay. Now, does these pumps run 24/7, or is there a like that shuts them off?
These pumps run whenever the system's enabled. Being that we are controlling domestic water, I would pretty much recommend that you leave them running all the time. Otherwise, the tank's going to cool down. You're not going to have it off for very long. I would recommend leaving it running, but it's up to you guys. We can kind of talk about that in the scheduling and stuff. But right now, whenever the system's running, these pumps will run. They are not tied to an Occupancy that will allow them to run at a certain temperature.
Is the reset on that thermostat?
I'm sorry?
The reset?
The reset, it is a push button on the top of that. Unfortunately, it is high up there, but hopefully you're not going to have to deal with it very often. It's more just a fail-safe.
Yeah.
So, kind of continue on. So we do have these two meters right here. This is your hot water system. This is your chilled water system. These both feed into the BMS system, so you have the ability to track your tonnage, how much you're using, your BTUs per hour, your flow rates, all that kind of stuff. We use individual sensors. It gives it a lot better accuracy to the meters to individually calibrated sensors. So both of these do feed into the BMS system.
Where are the chilled water flow sensors?
Chilled water flow sensor is, I think it's in there.
There it is. Those have to be serviced every year, I believe.
You know, they in a clean system like what you have here, I think they're okay. In a condenser water system where it's open atmosphere and you get some stuff, you would want to service those about once a year. They do use it's a turbine. It's got a little turbine in it, very fine. So if you get a lot of debris in it, if you have a dirty system, you will have to service it. What you would do with that is you can service it live. I don't know if you guys are familiar with these or not, but okay.
Well, they sit in a well.
Well, actually, these ones don't. It's a one-inch full port ball valve. So what would happen is there's a little nut. We can not really easy to look at with you, but there's a nut right there. Can you see it right here? Okay. See it right here. That's your device right here. And see right here, your hand valve. Okay. So what you do is you loosen the nut on it, hold your hand on it because it's under pressure. It'll slide the thing up. So you then isolate the hand valve shut, so now it's free from the system, and then just take it out. The way you clean it is, and it's all on the O&M, but basically you take some CLR, swish it around, just kind of clean it up. They're very good. You shouldn't have to clean it very often in this type of system. If it was in the condenser water system, once a year, so I would definitely recommend just dirty. And then, so, while we're there right here real quick, there's your Onicon sensor right there. You can tell by the different boxes. They're like more of a handy box. And there is your Johnson sensor right there. If you keep going down, you have your two pumps right here. The way these pumps work is we run it's a lead lag. So we run one pump until it gets up to 90%, I believe. If it runs at 90% for a certain amount of time, it calls for the lag pump to run. Then that lag pump then runs until, I believe it gets below 30 hertz, or 30%, I'm sorry, and then the lag pump will drop off. So potentially you will keep both pumps running, but not always.
So then on the drive, our lowest point is what,
15 hertz.
15
minimum.
60, of course.
Yep.
Okay. Now, can we change lead lag? Because what's going to happen is we're going to get a lot of running time on the lead, and the lag on that run.
Excuse me, absolutely. So what happens is what we have a schedule for, and we can change it or whatever, but I think by default, once a month, it'll rotate. By default, the system, every time it calls for a pump to run, it's going to automatically rotate the ones with the lowest run time. On your indirect system, your chilled water system, that makes sense. Every day, basically, whenever it calls, it'll switch. On this system, since we are running domestic, and you're probably open until 10 o'clock, you probably start again at 7, you need that warm-up, cool-down time, you're probably not going to shut this down. We will want to utilize that schedule to allow the pumps to rotate. What happens then is when we say rotate, it just switches to whatever has the lowest runtime to be lead. They both run for a couple of minutes at the same speed, and then it drops the live one off. So this right here is your control panel. You guys have keys, I'm sure?
Yeah.
They need one.
Let's see. Here's a couple keys for you. We do use a universal key, so it's the same key that will fit all our panels. So in here you have your two controllers, and you guys are probably familiar with FPCs and IOMs. Okay. Here's the brand new advanced module. Here's your relays right here. The different relays, one's for the flow switch, one's for the high temperature alarm, one's for the steam valve, and the other one is for a drain valve on the FPC. We've left some of your manuals in here, some of the original. These are like calibration sheets for your BTU meters and stuff. Whatever you want to do with them,
You have the wiring schematic for that you can put on the inside of that panel. So we know what relay is what wires are going to which point.
I'll do that when we do our final as-built. I'll just come out and we'll do that.
That would be really nice. Thank you.
No problem. Yeah, I mean, after a while you kind of, which one's which, so yeah, not a problem. This is another brake glass thing, so if you bust your brake glass, another way.
Now, on the ice cubes, if they're not lit, that means that they're off.
Exactly.
So a schedule or...
Well, and I wish I would have had them labeled here, but I'll put the drawing here. So
Okay.
one of them, this is your flow switch. I believe this is your high temperature alarm, and this is your emergency switch, I believe. These should always be lit. If you have flow, this one's lit.
Right.
If your high temperature alarm is not tripped, this one's lit. And if you have, if the emergency's not tripped, then it's lit. So generally these will always be lit. So if they're not lit, that'll be your first indication.
There's something.
Obviously you get an alarm, you look at the BMS for all that stuff, but if you're just here, lights are running, you look at that.
Okay.
And I can make note on the schedule, on or off, or when we open and close if we want. So while we're in this room, let's look at the domestic real quick and then we'll go into the tunnel. So here you have three different pumps. You have VCP2, so this is 1, and this is 3. And this is your little tiny heat exchanger for the domestic. This valve right here is what's controlling the temperature going, the water going into the system right here. We're trying to maintain 110. If it gets too high or too low, we'll alarm with it.
So the tank sits at 110?
I believe it's just at 110, yeah.
Is there any way, or Legionella grows below 140, so that tank needs to be surged with 140 about once a week or something like that to kill Legionella?
I've heard of Legionella, I never really had that come up before.
Really? Yeah. I've talked to my plumbers, they all either set our storage tanks at 140 or they surge them, so.
See, the issue with doing it is because out of this tank right here, it goes up to a research pump and goes out to the building. So if I set 140 to it, it's hot water. You know, it's really hot.
Maybe we'll have to manually do it once a month on a Sunday or something.
Yeah.
Circulate it for a few.
Yeah. That's a good point. I mean, would you like their domestic just send a little hot water heater doesn't do it, does it?
At your home? I don't know. We do them here though. So I've talked to other facilities managers.
Well, let me know how you want to, what you need to do, or if that's what you need to do, and I'll help you accommodate that. As of right now, we're trying to maintain 110. We don't want to spoil anybody, get anything too hot. You know, you might have a big enough flow that you're restricting the water to. I don't know enough about that Legionnaires disease to say, but so let me know if you need some help from me on that. But that valve right there is what's controlling the water temperature going in. Going up here, guess there might not be a light here. A couple things. This right here is a flow meter. It's just a pulse meter, just let you know how much water you're putting into your tower. Coming down through here, this is your solid separator, which I'm hoping somebody else is going to train you on because I don't know enough about it. I don't know why it's off. Do you know why the cooling tower system's off in general?
I thought it was Johnson's.
Somebody's got the VFD off outside, and somebody's got all the condenser water pumps off, and somebody's got this off. So
Let me go ask.
if it's not you guys, we need to figure out why everything's off.
Okay.
But this is your solid separator. You guys probably already understand the basic concept of it. But whenever a condenser water pump is running, we enable this system to run. So this pump will run through, it'll go through the system, and then whenever the system, this automatically will blow down on it as needed, and then, which is, it's got its own valve right here if you can see it. And I don't, they'll have to tell you when it blows down. It's probably off a timer, but it'll blow down as needed. This valve right here is what's tied to your chemical treatment system, which is in the other room there.
Which we got them in like other places as well.
Okay, yeah. So whenever it calls for the system to blow down, this is where it blows down right here. There is a drain valve right here. It's not used for anything at this point, but
Back in the old days, we used to have a tank here that had sand. It would flow through the sand to filter them back, and then it would actually dump it.
okay. Huh.
So evidently this has come a long way, so
I believe this is like a vortex where it spins.
spins it down.
Yeah, and
Okay,
then all
okay.
the solids go to the center, the outside of it, I can't remember, then go down and flush out. So.
Because we've got a simmer on the east tower, and it goes by, it gets up to about 25 pounds on it, and then it'll dump, and then it'll actually backflow.
Okay.
Out.
Huh.
It'll flush, and it goes through sand. Well, not sand, but that white stuff, earth.
Huh. Like really fine, I guess?
Real fine stuff.
That's pretty cool.
And that thing gets changed every so long. It's got to be re-dumped, and we have to put in a new sand and stuff.
Huh, that's interesting. All right, so
Do we have a pump to dump the water that goes into this?
you know, that's a lot. That's a plumber. I don't know how it's sloped, or maybe I don't know how that. There is some pumps in the other rooms, but in here I don't know how that's.
I mean, if we need to put a pump in there, well, we could. We could put a submersible pump and then run a line somewhere out to the nearest drain.
Okay.
But yeah, they've got well, right there.
There's a drink there. So it very well might go to that sump over, tied to that sump in that other room, maybe.
That maybe it does. Yeah.
So, and PHE or somebody else will probably let you know a little more about it, but your system, you do have to manually drain this tower, and you do need to manually shut it off. And there's has anybody showed you where the makeup, the manual shut off?
Nobody showed us nothing about that thing.
We'll need to make sure PHE, and maybe I think the training's going on all day today, so hopefully somebody will show you, because I'm not sure, but they are manual valves to stop.
This afternoon.
Okay.
But is there an automatic valve that'll dump when it gets so cold, the air temperature, and it opens up the valve, dump it? No. It doesn't have that.
There is a drain valve, but it's not tied to anything right now. It was just part of it was in the drawings to do. The engineer said, let's leave it in, but it's not tied to a sequence. The issue with that is I don't have a valve on the makeup. So I could drain it, but your makeup's still going, so you're just constantly done.
Yeah.
One thing you might want to add in the future is if we could just add a valve, you know, and even if you use the same signal,
So
you know,
we just, yeah.
a lot of times what we'll do is we'll drain it when it gets too cold at night or something like that. If it gets below 35, we'll just dump the tower. Right now I have no way of doing that. You will get an alarm that says it's been below 35 degrees, I believe, for 5 hours, so it'll give you an alarm, but I can't do anything about it.
But that's okay for now. Yeah.
I mean, you guys are fortunate that you have a really nice system here. You have chilled water and stuff. So at some point, you're probably going to say, we're done with indirect. We're just going to dump it and deal with our other system for the short period. So, all right. Well, we'll go back up here then. So now we're in the east mechanical room. East, we've got all the mechanical, the pumps and the air handler one, I believe. So let's just start this way and move our way back. Somebody else will probably train you a little bit more on the evap section, the internals inside. But we'll just start this way and go back. This right here is your pump control. what we do is we enable the pump on and off for your evap section. It does have a low level sensor in it. It's a sensor that says that it gets below this to disable the pump from running. So that evap pump, if you get an alarm that says the status doesn't match the command, there's a good chance you might not have any water in it. So
We got a lot of them on the last couple of weeks.
Oh, have you?
Yeah.
The pump status alarm?
It said it didn't match the status.
We need to look at that.
Yeah.
These ones should be up and running and good. The pump over on that other side,
Well, the pan's
had
dry,
an issue.
so-
Yeah, it would have drained down. It's not warm enough probably yet to turn on, but we'll have to look at whatever alarms you're getting. Here you have your typical high duct static sensor. It's set up 5 inches on both of them. So that's your high pressure alarm. This right here is going to be your makeup, or well, the evap section. The first one I believe is your makeup, and we can look in there to double check. I believe this is your makeup. This is your flush, and this is your drain. And so by default, these fail closed, this fails open. Spring. Yep. And so in an off position, we keep that drain valve open, that way in case something's leaking by, it just dumps down the drain. You still would have overflows and all that kind of stuff, but it's actually a really nice evap section you have in there. It's really nice. So, those are your valves there. Keep going down this way.
So the valve on the drain, it shuts when it's full and when it's off.
So let me give you a little bit better idea of how this works. So when we go to the evap mode, and we'll talk a little bit more about that on the computer, but which is state free, the first thing we do is we shut the drain valve. We then open the makeup valve. The makeup valve then stays open. We have a timer in there. It's set for every 15 minutes. So we just let the system run for 15 minutes, and that just fills the pan up. After the 15 minutes, we fire the pump. Now we're dumping water over the system. It'll stay like that the entire day until a couple things happen. One, if our return air humidity gets above 50%, we shut it down. If our outside air dew point gets above 54 degrees, we shut it down. Otherwise, it'll stay running all day until the end of the day. We do a flush command, which is, we'll talk about the scheduling on that. But an hour before we shut the air handler down, we send a flush command. What happens then, we open the drain valve, shut the makeup, we allow the pan to drain down for 15 minutes. After that, we open the flush valve and keep the drain valve open. So now the flush valve is there to clean the pan out, to get all whatever media is dropped out just to flush the pan. That stays that way for an additional 15 minutes, I believe. And all these times are adjustable. After that, flush will shut, drain will stay open, and then we just allow the media to dry out for about another half an hour or so, and then the unit would shut down.
This is the first of the series of to cool down the building.
Yeah, exactly.
Because there's 3. This is number 1, the tower is number 2,
Exactly.
and the chilled loop is 3.
Exactly.
Now, they will not work together, one or the other.
It actually will all work together.
Really?
There's a chance where you could have all 3 of these systems running together.
Okay.
Generally, you won't have to be that way, but the system would allow you to. There's a couple things with the evaps, like you said, if you're, besides the lockout, so if we got above 50%, we would shut the pump off. If the dew point got too high outside, we would shut off. There's also just a latch, you can shut it off, so if you don't want it to run. What we've done on some systems is we've done predictive weather, so we can say tomorrow it's going to rain.
So you
don't run
put in
the
that,
evap section.
okay, yeah.
It's not something, I don't think you guys have weather stuff, but it's something that we've done in the past that we can do for you, but we look at the weather. So if you guys know it's going to be raining the next day, you might say, I don't even want to run the evap section, just leave it off, and it would skip states to just avoid that. But there is a potential you run the evap section, it'll run until it can't maintain anymore. And on a really good dry day, that's probably all you'll need. But when it gets a little bit more humidity in the air, you don't get as much cooling out of it. You'll then call for the indirect. Your tower, if you have an issue with the tower, you're not able to get enough cooling out of it, we will then call for yeah. And I mean, honestly, exactly. Right now, I think pretty much since that tower's shut off, and I don't know if this is enabled or not, you probably are running most of your chill at this point.
Well, the chillers aren't on yet, but
Sure.
yeah, because of the temperature, because they're saying that 52.
And that's something I do want to fine tune with you guys, so maybe we can look at the system there, because I did a lot of outside air temp a couple different ways, but I really need to know when your system's running.
Well, we have it on the schedule, and then at a actual set point, a temperature set point.
Okay.
So if it gets above 52 and is not at the actually scheduled time, it's not going to be coming on until that scheduled time.
It's changing in the next month or two. Yeah. You guys are coming in and Greg, and we're reprogramming it all. So
We'll want to fine tune that a little bit. One of the concerns is because I'm a fan. Well, if I turn these pumps on and I don't have chilled water, I'm essentially using the air handler to cool that chilled water down, and it just doesn't sequence right.
Well, the way we cool every place else, which is outside air. And if it's above 55 degrees, then we need to have something else, because we're going to lose.
Yeah. Well, my concern when I see it happen
when
is
everything is set at like 52.
Yeah. Well, I just need to know that the chiller's running, that we are making cold water, because if I turn it on and say it's 20 degrees outside and somehow I got too hot and the pumps are running, my discharge air sensor's after, so I might be dumping 100% outside air. I'm heating this huge loop right here.
Right, yeah.
So anyways, we'll fine tune that, but just something I want to make sure we can take care of. As you go down these, you have your different coils. This is your chilled water coil. You just have your averaging element that just runs down the side of it. It's just there for monitoring purposes to let you know what kind of delta T you're getting.
And yet we have we don't have no isolation going into the air handler, right? So or is there isolation on this side?
Okay. There's some
up there. Yeah.
Same thing on the other side for your
It's got the water.
indirect. A couple of things. So I don't know if you can see, they kind of put it underneath the insulation, but there's a sensor up there.
Okay.
And that is actually your discharge air sensor. There's a bypass. Have you guys walked through these yet? You see the bypass in this yet? Okay. There's a bypass damper here, so when we're running the evap section, you guys have a really nice system where if we get too cold, generally like with an evap section, as soon as you turn it on, you can maybe get 20, 30 degrees delta T, a drop in temperature, which means you're 60 degrees, now it's really cold, you can subcool it. So we have the ability with this bypass damper to control how much air goes through the media and how much bypasses through it, so we get better mixing. What that means to you guys is this right here is your discharge air sensor, because this is what's actually going up the shaft and out to the building, not down here. We do have a sensor here, which has return of humidity and stuff, but it's not this is your controlling sensor right here.
If this goes down for whatever reason, does it go to the next stage, or what happens?
So the way the air handler stages is if we get 2 degrees, basically there's 5 different states. So when the air handler first turns on, it's going to look at, am I below 45 degrees? Yes, I'll start in preheat mode. Just means it's we're just trying to maintain minimum outside air. We're trying to maintain mixed air temperature that resets between 47 and 54 degrees. As the temperature gets warmer, we get 2 degrees above our set point, we then switch to the next state. We run for the evap for a while. If we couldn't make it, we're 2 degrees above that, we would go for the indirect. 2 degrees above that, we would go to the chill.
Are you counting on it sending its signal or its temperature to the next? If something were to happen in the first stage, didn't send a signal, and it needed to come on, where do we go from there?
So say for example the indirect didn't work and we were in state 4, or well, we were in state 3, which is the evap section. We didn't get any cooling out of it. We would automatically switch to the next state, and we could set up alarms for you if you want, but we would automatically just jump to the next one and use that for additional cooling and back and forth. Is that your question?
Well, yeah, because we would want to know if it's not working, we want to know, hey, we've got to get something there. And if it hasn't come on automatic, or maybe the next stage has failed as well, then we've got to get chilled water.
Yeah.
So we want to know what's
And we
going
can
on.
fine tune that a little bit, how the best way to alert you guys that you aren't getting cooling out of it. I'd have to think about that for a second, but when we're looking at the system, maybe let's come up with something.
And what could we do about it? Is there
Sure.
something that?
Because, I mean, you'll get an alarm that says, hey, I'm too warm, I'm like 65 degrees, but you want to know that I didn't get any anything out of the indirect, and I skipped it, like it is now, I guess, it's shut down, you don't know it.
Exactly. And so on.
We can figure something out, a way to, nothing was specifically called, but that's a good point, we can figure that out.
So basically, what I see is we got a hot deck, cold deck system.
There's only one deck, there's only one duct that actually goes out to the building.
Right.
So it's not a dual duct system, and that, I guess what I'm used to calling a dual duct.
Yeah.
You don't have a hot deck and a cold deck individually.
Well, that's what I'm saying. So because on the cold deck, then that's where your
Sensor is?
separation is between your various different runs.
Well, so what happens is if you look inside this unit, you'll see the Evap Dampers here. In every state except for the Evap mode, that's going to be shut.
Right.
And so normally it all goes through this, and it turns and goes right up the shaft.
Right.
But in an Evap section, if it gets too cold, I'll start modulating that damper, which means I'm bypassing the coils. No matter what, I'm still trying to maintain no higher than 54-degree air coming out of that space. So it's still a cold deck system. We mix the air a little bit different. Okay. So this right here is your VFD for the air handler. I'm not an expert on those ones, so go on. Control panel right here. Your IT guys have put plugs in here. This is an NCE. You guys are probably pretty familiar with these things. They're really nice. It's like an NAE and a controller built into one. It allows a lot more complexity in the programs and stuff. But this has an NCE. This does have, I don't know if it's activated or not, but you do have the ability to plug directly into the system and look at your whole campus right from down here. We had a couple wires out. We're adding, when we go up there, we'll talk about it. There's this part of the smoke system, there's no safety, so if somebody went in there and overrode something, you potentially suck your duct in. So we're adding a sensor. That's what these wires are for, and that's for right there. Just didn't want you to think there's left the wires undone now. Any questions with the NCE or anything? You're probably familiar with that system. Free stats. Right here you got 4 of them, as well as you're averaging. They're all set, I believe, at 37 or 35, right around there.
Are they hardwired or software?
Hardwired. And that's a good point. So I'll put the drawing on this one as well. One of them is your high duct static. The other one is your low temperature alarm. This one right here will be the low duct static. We were waiting for the sensor to mount that came in, so it's kind of a change to add that later. But anyways, on the air handlers, you always want these to be lit. If something's not lit, this is a hardwired safety that goes to the drive. If there should be a little bit down on the side.
Yeah.
Set up.
Yeah. When that red light's not on, you got
That's your safety relay. Yeah. So all these are run in series. So if any one of these trips out, that light will go off. The drive won't run.
on the freeze. That's they said at 35.
Between 35 and 37. I believe it's 35. Yeah. Yep.
Safety circle. How will we know?
As we go down, here's your heating coil right here, your preheat coil. Your valve for that is actually in the hallway right there, but there's a valve for it. It does run off a heat exchange right there, just for the glycol section. So just your normal building hot water going into one side, glycol on the other side. I don't know why this pump is off now, but we'll need to check with PHE. That should be on, but that's your. So when we call for preheat, your pump turns on, circulates water through. The valve modulates to maintain temperature. So As we go through here, on this device you have your return air humidity and return air CO2 and return of temperature sensor. This is actually kind of the plenum that we're in right now. You don't feel a lot of air move. This is the plenum. These are your return dampers here that are shut, so we are running in on economizer mode right now. We're kind of limited on the length of cables, but this right here is an Evap outside airflow sensor or station. I don't know if you can see it out there or not.
Yeah, okay.
You don't need to do anything with it. It's all wired back to the control system. But we are maintaining a minimum outside air flow. With this type of system where you do have the indirect, I don't know if you're familiar with it or not, but we will be running outside, 100% outside air a good majority of the time, unless it's really cold outside or really humid outside. Just because we're not using a economizer switchover based off, dry bulb or anything like that. So there's a good chance you'll be running 100% outside air most of the time. So these Evap sensors will have the O&Ms. We can look in that unit and look up, but they're just your standard gold probes with the 4 probes in them. You guys are probably pretty familiar with those. Just really good sensors. So that's the real brief overview of the air handler. We'll look on the other side. This right here acts into your tunnel here. You can fit in there, I guess. There's a ladder on the other side. But there's a differential pressure sensor on that antenna. We'll look at it there, I guess, but that's where your differential pressure sensor for your chilled water system is.
And your drives are for your chilled water pumps?
Yep, so over here, that's a good point. Yeah, the 2 drives here, condenser water pump 1 and 2, I guess. These are just on starters, HOA switches and everything.
So it doesn't have a salt, IGS start, you don't have salt.
No, on off. And these are just redundant pumps. You should only be running 1 of these pumps at a time. These are, I guess, a real quick point on these ones too is that we also have a safety on these ones. And this might be good where we label, because this might be a little bit confusing, because these are safeties, but these aren't. And I'll explain the difference here, but what we're doing is there's an ultrasonic level sensor in the cooling towers that measures the level. If the water gets too low, like there's no water in the sump, we actually lock out the pumps from running so you don't run the pumps dry. And so that is a safety there that won't allow the system to run if there's no water in it.
Are you guys going to put labels on these so we know which pumps they go to?
The mechanical or electrical should do that. If not, I can get a label maker, but they
make an email.
Yeah, they should label. Looks like the electricians put the circuit on it. They wrote in hand what the pumps are, but
well, they're equipping alarms.
Well,
but they have not been programmed. More than likely.
They've been programmed and running. What it was, it probably had a power failure or something. They say Johnson Controls, but it's actually Bissell manufacturer. They bought the parts and put it all together. They assemble this part, so that's who we'll want to.
But then again, when you're not showing the exterior fault.
I'm not an expert with this, so I don't want to explain too much with them. But you're right now you're in a fault because I'm not giving you a start command. We'll have to talk with them about why it shows a fault.
Exactly.
Because it should show a fault.
Why aren't we showing it on a line? It should be an external fault.
Well, it's actually not even a fault. We're just not calling for the chill water pump to run.
Okay.
So why this light's flashing?
Okay.
Yeah, that's something we would want to talk with them about.
Okay.
Let's shut one of these off real quick. I'll show you.
Need a pocket knife?
Yeah, I think I got one.
Chill water is not, these are VFDs here, right?
Yes, they are.
Control. How many ones that are on? Is that condenser water?
Yep.
They just full blast.
Good.
get too much in there.
I just figured we'd take this quick opportunity to show you. All the VFDs we're measuring, so all the VFDs we have a transducer, and what we're doing is we're actually measuring the current draw through it. All the pumps that are just on the starter, like an HOA switch or just the starter, those actually use current switches, so it's just off or on. You're probably pretty familiar with those, right?
So does that take place on those round the donuts that used to be on them to read the actual circuit?
Yeah, so this one still has it. And this is just a switch, it's just on or off. And so it'll just say pumps running or not, just pretty standard. This one right here is a transducer, so what we're doing is we're actually getting because that pump, it's on or off, it's a constant speed, so it's the same amount of current draw generally. This one right here, since it wraps up and down, we want to know what the different current is. And so I just wanted to point out all the VFDs, so all your pumps, air handlers, that all use an analog transducer to measure the current, not a switch. So, and the reason I pointed that out is because this right here is your command, because it's not a combo relay. If that makes sense. Yeah, try to get this.
Now you're making a fall. Nope.
Yeah. Well, when it first starts up, it goes to a fall.
Yeah.
And this is something that they'll.
Yeah, they got like two.
The other thing is it shouldn't say start of the system. It shouldn't have any of that either. But
There's a lot of bugs in there. I'm not saying a lot.
What's that?
There's bugs in it that still need to be.
I don't know. I didn't provide them. It says Johnson Controls, but they bought the parts and there's some manufacturer builds them. I don't know enough about it. All I can say is the reason it says alarm is because I'm not giving it a command to run. It's really not an alarm right now.
But are you coming to make sure that things are going to run the way they should, or is that going to be up to somebody else? Or
That would be something for PHE. That would be PHE's issue, the mechanical contractor. And I can let them know, or maybe Daniel can talk with them or Blake about it or whatnot. But
if within a year, whatever the warranty is that
It's a year.
who gets called? So the boss here,
Yeah.
they do all the work on this.
Vista Manufacturing, they just manufacture the
For
VFDs.
the PHE that you said.
Oh, they're the mechanical, so they're just the contractor that provided them. They probably wouldn't be able to service them, but they did provide them.
But if someone was wrong with them right away,
The PHE would be the one that we would, well, Oakland and PHE would be the ones that would address that. Absolutely.
we really wouldn't touch anything, not for a while, not for
Yeah.
years, right?
Yeah.
We can get familiar and come in and
Look at stuff, and yeah, exactly. But if you have issues at this point, it should be somebody else that takes care of it.
Yeah.
And, as far as this stuff, I mean, I'd be more than happy to talk to PHE or Blake and let them know what the confusion is. I can't do anything to fix it, but I can at least explain to them what the problem is and what they need to do to make it clear for you guys. When you walk in, you see fault, you think something's wrong, not right.
So here's your chilled water.
Same thing, FECH clean panel. This right here is your transducer. This is what feeds your ultrasonic sensor, which we'll look at out of the towers, but about the only thing different in here. Going down, you have chemical treatment right here. We don't have much to do with that, but that is what pops that Glimo blow down valve in there. We also have an alarm if your conductivity stuff gets too high. Or if you get an alarm. Any questions in here?
No, I think we're good. I think we're ready to move to part 3.
Okay, so we're just in one of the elevator rooms on the east side of the basement real quick to show a demonstration of some of the fan coil units and how we're controlling them. With the fan coils, I believe there's actually a total of 26 or so. There's quite a few of them, but the ones that are in critical rooms, so every one of your comm rooms has a fan coil unit, cooling only. Everyone, the elevator room, the PS room, generator room, transfer switch room has one as well, and then all your comm rooms. So basically there's 12 critical units. So of these 12 critical units, the way things work is that you have a standalone control right here, and the room is fed off the air handler for fresh air, and it's also, as a supplement to it, it does have a fan coil unit. So when the air handler shuts down or whatnot, it does have a fan coil unit that can turn the fan on and blow chilled air through the room to circulate space. We do have an alarm in these 12 critical areas. We do have a flat plate sensor, which is actually a temperature sensor that does respond back to the medicine system that will alarm you if it gets too hot or too cold. And we do have the ability to, that we can enable the air handler to turn on to provide cooling if it got too hot. And this is something we'll need to fine tune a little bit with your chilled water system, because we'll just work out a couple of keys how we want to do that. But I just want to make a point that these are your thermostats. This is your temperature sensor. All the ones in these rooms have adjustable dials on it, so you can adjust the temperature up and down. The ones that are in the common areas, all your stairwells, vestibules and stuff, those do not have the ability to adjust. We've taken the sensor off. You guys can get in and adjust them, but they are just standalone without adjustment, so you don't have kids in there playing around with them. So now we're out in the cooling tower room. We'll quickly show you a couple of sensors and stuff. The way your makeup work is just off a float right there, just goes up and down to fill and drain. And that's and so that's why I was saying
wall cock.
If I can't just open the drain valve, because then the makeup would
exactly.
Up and through. So this right here is your ultrasonic level sensor. We put it in a standpipe like that, and those zip ties are there for a reason. We don't want to drill metal into the cooling tower because it causes corrosion and rust. So those zip ties are strong. Zip ties are there for a reason like that, but it's in a standpipe, and the reason why we do that is because all the turbulence in it, the water dumping down, it provides turbulence, so that provides a more stable linear flow through it. It's not used for controlling the water level. All it is just a monitoring point. It'll do two things for you. The first thing is it'll say if it gets too cold and we show that there's water in there, it'll give you an alarm. If there's no water in it and it gets too cold, it won't give you an alarm. The other thing it does is it does the low level lockout. And so if it gets, the water gets below 10 inches, I can't remember where it is below, but below where it starts sucking air in, it'll shut the pumps off, and that would require you to manually reset that so you don't get into we've seen an issue where you shut the pumps off and then it shuts down, you turn it back on, the water fills back up, and it just goes back and forth, so it will shut down.
Well, if we were able to put a valve right here, a electric valve for our fill, how far would we have to run the wires?
You can actually install it in the mechanical room.
Yeah,
in the mechanical room, but we still need to shut the makeup off. That was what he was saying.
Well, we can shut the makeup off down below. Because this is actually fed in that mechanical room that we just
in the mechanical room, but you're saying that the reason why is that the makeup, we cannot control the makeup.
Right now it's just a hand valve.
Hand valve, exactly.
But if we were to add a control valve,
so that valve would be downstairs, so you would install it to the makeup down there.
Exactly. If we did that though, it would require a little bit of thought as far as putting some heat trace on this line here or something like that, or at least wrapping it really good. So you wouldn't want to keep, you still have to drain it, but that small water would freeze a little easier. You do have if you look at that sensor, that's your sub-temperature sensor. It's just a well inside there that's what we're using for monitoring. If we don't control off that sensor, it's just going to say, hey, you're too cold, issue an alarm.
Or so there's an alarm, they're about to deal with it. Okay.
Exactly. So your VFD here, there is a vibration. Yep, for the fan. There is a vibration sensor inside it. It is a manual reset that is tied to the BMS.
Is it a gearbox or is it a belt?
I believe it's a belt, isn't it? Drag? I don't remember.
You guys, then there would be a secondary alarm on low loop.
There is
and
no
by vibration, and if there's not a large
There would be a
loop,
yeah.
it would have to be a belt driven.
Belt.
Okay.
Belt, okay, then it's not a gearbox. Good.
So just a vibration alarm, but you will get that through medicines, but that does shut down the drive. That does make it go to fault and
Yeah.
prevents it from running.
But you have to go
so.
there to reset the shaker box.
Exactly. Yep. You do need to go back up there to get that changed. So.
Okay.
All right. So now we're up on the roof, looking at some of the relief fans, some outdoor air sensors, and that type of stuff. When we came up here, we noticed that one of the relief fans is not running. This is
But aren't they controlled by the static?
Yep.
So if it doesn't need to be on, it's not going to be on.
Well, that's a very good question. So the way that this works is we have two different building pressure sensors and a total of 5 relief fans. We have, I believe it's 1, 2, and 5, which is in the middle of the building. And they're kind of the main one that do the atrium area, kind of that big open space. But they all run, these 3 fans run together. So our first stage is we modulate the dampers open and close to relieve the pressure. If we're still above pressure, we would then enable the exhaust or the relief fans to run, and then they would all ramp up and down together. So my indication that something's not right is one's running and the other one's not. They should all be running together.
And that's why you get the drive for them to ramp up
Exactly.
or they would ramp down.
Exactly. Exactly. So right now, where it's a little warmer, probably around 100% outside air, we are needing some relief. You know, as we get colder, we're not bringing as much outside air. The relief fans will probably shut off, and just your dampers will modulate back and forth.
By coming in, the doors, I mean, when they're not being pushed open, when that's a clue right there, that we're not in a high
Exactly.
static.
So, and you know, in my opinion, building pressure is a little bit different in every building. I can't remember where I set it. I think 0.05, 06, I don't remember. But you might need to raise it up or down a little bit. I mean, as long as you're not, in the wintertime, it's real important that we don't make it go negative. So then you're sucking all that cold air in, you know. And in the summertime, we don't want to be too positive, so we're blowing all that conditioned air out. So, but right over here, I just noticed that it was, one of them wasn't running. It looks like there's been a fault.
Okay.
It said
So-
37, you had a 37, so is that the number? I mean, did you look up on the chart?
It doesn't have just a wire. I don't know what that is. We would have to check with the Bissell manufacturer to see what they
That's
said.
37 if I had a bunch of others.
Yeah.
Just look at it and find that correction where it's from.
It looks like that did take care of the immediate problem, so we'll have to have them look and see what they.
Yeah, transfer.
Okay, so now we're over on the east side of the roof, and so here I'm going to show you. This is your outside air temperature, or outside air temperature sensor, outside air humidity sensor, and your building pressure sensor for the atrium. These the temperature sensors all run down to the air handler that's down here, which is air handler 1. So that's where the physical connection is.
So that runs everything here.
This is your.
That particular outside air sensor.
It does the whole building.
The whole building.
Okay. And it really should be in a pretty good spot, especially with this. It should be in the shade most of the time. You get a pretty good reading for it. But that is your one building pressure right there. The other one's on the other side. I'll show you as we make our way over there.
Okay, and that's on the south side. What the other one that you're talking about?
Oh, the other building pressure is going to be. I can't remember exactly how it is.
Okay.
We'll see when we get over there. So exhaust fans wise, we missed the one over there, but as we came by next to the 2 roofs, the 2 relief fans, there's a big dome exhaust fan. That was exhaust fan, I believe, 1. This right, exhaust fan 2. This is exhaust fan 1. I believe that they do the east and west general exhaust, bathrooms, and that type of stuff that come up. There's an exhaust fan 3, which does the mail cart charging area, which I'll show you in a minute. There's EF4, which is a standalone one for, I believe, for the president's bathroom, which is, I believe, tied off a light switch and occupancy sensor, so we don't control it. It's just there. And then there's an EF5 that I'm not sure what to check on, but was tied to the AV cabinet. I'll show you that here in a second. So here we're on the 4th floor of the west side. I just want to show you real quickly. These are the VFDs for the relief fans that are on the other side of the wall there. So these are the fans here. These right here, real quickly, this is the control for where the relief fan is.
that's just a transformer. That's one of the ones that feeds all the VAV boxes. You're probably familiar with those. The way that we powered all the VAVs is they all go back to a 500 VA circuit, or a 500 VA transformer, which has individual 100 VA circuits, so it's still a class 2 circuit. And basically we run about 5 VAVs per transformer per 100 VAV circuit. And so typically these will run about 25 boxes. So they're spread throughout, and they'll be on the drawings, the locations of where they're at. So, one thing I guess we should point out as well, and I guess we can confirm with the BF guy, but we have relief on the dampers. We have end switches for these relief fans. What we're doing with that is we don't want somebody to come into the VFD in hand or just override the VFD on with the dampers being shut and blow off. So we are tied to the safety circuit of these VFDs on the relief fans, the 5 of them, that says if the damper's not open, it goes to the safety, shuts down the VFD so it won't run. I just want to bring that to your attention. So, okay. So, here. All right, real quickly, as we're coming down, I just want to show you this building has a total of 2 NAEs. One of them is located on the 3rd floor of the telecom room, which is right here. This is an NAE 45. This is what communicates with the entire 3rd floor and 4th floor. Down on the 1st floor, we have an NAE 55 that communicates with the 1st floor and the 2nd floor VAV boxes and peripheral equipment. Everything except for the stuff that's in the mechanic rooms down in the basement.
Both east and west side?
No, we just have them on the west side.
Okay, so communicating to the east side, poles to here, or poles to another side?
No, poles to here, poles to there. Yep. So one trunk, so on the NAE 55, the one trunk does the entire 1st floor all the way across. The other trunk does the entire 2nd floor all the way back and forth. And this one does the whole 3rd floor as well as the 4th floor. So I just want to show you the NAE right here. So,
What's that box?
it was like access control. It was access control. These right here, as you can see, I guess these are your fan coils right here. The mixing box just stays open at this point. That's your house air coming in. Thermostat, like what we talked about, this is one of the critical rooms with the flat foot wall sensor there as well. So.
Cool. And then just a minute.
That's there. The duct,
Yeah.
around. That's fed directly out the house air, off the air handler, so it's 55. Degree air, we're not just blowing in. So typically in the daytime while this is running, we should be okay with just feeding off that house air. And the biggest thing we have to worry about is at night when it's things shut off. What we do about that. So, a typical classroom, I believe it's level 3, room 314. Here we'll just real quickly talk about some of the VAV boxes and some of the sensors. If you look here on the wall here, you see the sensor without any sort of a display on it. That's going to be a CO2 sensor, and this right here is your zone sensor. The way the CO2 works is they're only in the pretty much the classrooms, wherever it's highly a lot of people in them, and that's there to control the minimum ventilation of the room. We just want to maintain a minimum ventilation. We want to maintain no more than 800 parts per million of CO2, I believe. And so, as there's no, excuse me, that'll reset the ventilation minimum from all the way down to 0 up to a maximum setting of that VAV box. So that's the CO2 sensor. This right here is your thermostat right here, and I believe you have some questions on how that works. Yeah. So to give you kind of an overview of the way the VAV box works, so right now we're dumping 55, roughly 55 degree air into the VAV. All of these boxes that have an occupancy sensor tied to them, like this room right here, that's an occupancy sensor that's tied to the VAV box. What happens is right now when nobody's in this room, or when nobody was in this room, the VAV box can actually go to a minimum CFM setting of 0. We're still going to try to maintain the room temperature, whatever that set point is, 71 or 72, whatever it is. We're going to maintain that room temperature, but if nobody's in here, we're not going to waste the energy to dump air into the space. As soon as somebody comes in the space, we actually do have a minimum ventilation where we will blow fresh air into the room, just to keep the air clean. So that's kind of a key thing to note, that there is occupancy sensors, and some of these where we get to offices, one VAV may serve several different offices. Wherever there's occupancy sensors tied to that VAV box.
Well, how does it shut off the air? I mean, what is the purpose, I mean, because it,
Yeah, great question.
does it shut off the actual, the valve, the heat valve?
What it does is that it's an input that goes directly back to our controller. When our controller says nobody's in here,
Right.
it then shuts the damper
Well, the damper.
on the VAV box.
VAV box.
Exactly. So.
Is there a certain temperature that keeps it constantly? You say it goes to zero. Is zero?
It goes to, the ventilation will go to a minimum of 0 CFM, but our ultimate goal is we need to maintain the temperature of the space. So we don't want it to get too cold or too warm in here. So even if nobody's in the room and it gets too cold, the VAV box will act normal. It'll open up the damper, control the heat valve and so forth to maintain that zone set point.
Because you don't want to come in and all of a sudden take it an hour, a half hour.
Exactly.
get
So
back
the
up.
goal is to maintain comfort in the space, but to save energy at the same time. By maintaining temperature when nobody's in here, you don't have much of a load. You don't need much ventilation in here. You go quite a while without adding anything, but at least we're maintaining that
So
temperature.
this CO2 sensor, that eliminates your 15 percent
Exactly.
dampers, the
The minimum fresh air requirement.
fresh air
Exactly.
requirement.
It eliminates
So
that.
the building will get sick.
Exactly. So, all right, go ahead. All right, what was your question again, real quick?
My question is, then they're gonna be able to come and set the stat here whenever they feel like it, that are controlled by.
Very good question. So the way that this works is any of the thermostats that are in public places, and what I mean by that is corridors, hallways, that type of stuff, we've eliminated the ability to adjust the thermostat. You guys have the ultimate control over that. In the system, you'll adjust the zone set point to whatever you want because you don't want all over the place. In the classrooms and offices and that type of stuff, I've actually believe we've left the control in there for them, but we've limited the range that they can control it to. By default, you can go from 55 to 85.
Right.
We need to maintain a more
So it's
consistent.
a four.
Well, we have it's a 4 degree deadband, but our adjustability on it, I believe, is 68 to 74. So, and we can actually look at it really quickly. If you rotate the dial, yeah, 68 is the coldest,
68.
and the warmest is 74.
74.
Yep.
So, okay.
Excuse me.
That
So-
should help eliminate some
Yeah,
of the
that'd
calls.
be
Yeah.
cool.
And I guess a couple key points with that is, so the way the VAV works is it looks at the zone temperature, whatever the zone temperature is, and then it looks at the zone set point. That zone set point has a 4 degree deadband. What I mean by that is if your zone set point is 72 degrees, your effective heating is 68, your effective cooling is 70, what did I say, 70?
74.
Yeah.
Oh,
Yeah,
72.
I'm sorry, 70 is, if your zone set point was 72, your effective heating would be 70, your effective cooling would be 74. In that deadband, we're just gonna be blowing, if needed, we would just blow minimum ventilation. We just don't wanna have too much cycling. And typical for a classroom and office, that'll be just fine. If you feel like you need to shorten that deadband up, we can. But just know, when we look at the computer, I'll explain a little bit more, but it's the effective cooling and the effective heating set point that really dictate whether or not we're heating or cooling the space. To give you a quick rundown of the way these thermostats work is, as you saw, the first thing when you look at it just reads what the zone temperature of the room is. As you adjust it, it'll start flashing, and that's now I'm adjusting what the zone set point is. When I find out where I want my zone set point, I just let go. It'll stop flashing after a second, and then that is your new effective zone set point.
Now, can we lock that in over the heat plant? If it's too much monkeying around.
Absolutely.
Or we can lock it in and just say, boom, 72, leave it alone.
Absolutely.
So they can turn all they want, but they're
A
gonna
couple different
change
things we can do. We can limit the range. So instead of 68 to 74, you might give them 1 or 2 degrees so they can play with it.
Yeah.
You can also just override it. You can let them think that they're changing it. A lot of
Yeah.
times it's a mental thing, and
It's true.
you can do it that way. But I'll show you.
And we've done that quite a bit.
Yeah. The other thing you'll notice is there's a little button that says F and C. When you look at a sensor that says 21, it might be Celsius. The thermostat has the ability to read Fahrenheit or Celsius. It does not affect the programming or the way it works. It's just simply a display of what that zone temperature is. And so if you look at that or somebody's freaking out that it's 21 degrees, it's probably Celsius. The other thing is if you look, there's a guy in a house there on that thermostat. Let me turn that light on if you need to rotate a little bit, but if you rotate, let's see, yeah. What that's for is that's the occupancy. So right now the room is occupied, the guy is in his house. Some of these spaces have the ability to do a temporary occupied override. So what that is if you decide to have a schedule for some of your offices from 7 to 5 and somebody comes in at 6 or 7 o'clock and wants to run the unit, their guy will be out of his house, which means he's unoccupied. As soon as they rotate that thermostat, it then makes it occupied. It turns them into occupied mode, and the VAV will control that way for, I believe it's an hour and a half, to give them that temporary control.
Good idea, yeah.
Does it turn the air handler on at night?
If need be, it will, yeah. But I don't think you'll have that much of an issue with it, but yes.
So for one room, for one guy,
Uh-huh.
turn on the air handler,
Yeah.
that's unbelievable.
Yeah. Well, and
Just for
it's all
some
adjustable. I mean, we
moments,
can
Yeah.
take people out of that, add people into whatever you
Yeah.
want to do,
Yeah.
but by default, they can turn it on or off. In the school, I don't think it'll be as bad because you probably have classes till 10 o'clock at night,
True.
whatever.
Yeah.
But either way, it is all adjustable. Real quickly, let's take a quick moment to go over the VAV sequencing. So the way that the VAV works is we're going to have a minimum ventilation on certain, say it's 200 CFM. As the room gets further out of range as far as it goes to cooling mode, we then reset that damper position between a minimum and a maximum position, which resets the amount of air going into the space, but we are just blowing that conditioned air from the air handler at 55, 54 degrees, whatever it is. When we go to a heating mode, when it gets below set point, what we do is, the first thing we do is we have a pin that starts modulating a reheat valve. That reheat valve will modulate between 55 and 85 degrees for your discharge air temperature. And once it gets to above 85 degrees, we then reset the heating airflow between the minimum and the maximum, but we're still trying to maintain that consistent discharge air temperature of around 85 degrees. So you might look at the system and say, I'm really cold, why is my heating valve not 100% open? The reason is we're trying to maintain no more than 85 degrees coming out of it. And the logic behind it is if you look around and you see some of the diffusers, if you dump too much hot air into the space, the hot air stays high and it just sucks through the return and you're not getting good mixing. By lowering the discharge air to no more than 85, you still allow heating, but it mixes throughout the room a little bit better. So that's kind of why it's that way, but don't get concerned if you're not if your heating valve's not 100% open, that's probably why. You'll see on the graphic where it's going to have an effective discharge air temperature set point. It's not, when we first go to heating, it's not going to go right to 85. It'll start going 75, 76, and try and maintain it that way. But real quick, that's how it works. There's also radiant valves. These are actually radiant panels right here above some of the areas. What that is just tied to the pin of the VAV box. There's a heating pin. As the pin gets above 15%, we open up the heating, that radiant valve is just open or closed, opens that up, and then when it gets below 10%, it shuts off again.
What that does is it puts that
Kind of
blanket
air
of warm air
curtain.
curtain on that window to keep
Exactly.
cold from coming in.
Exactly. So, and there is the ability to disable the radiant if you need to, or whatnot. So.
Okay.
There is also a point where you can disable all the heating enabled, so if you don't have your heating enabled, or if you shut your heat, I don't think you'll do it here, but if you're shutting off your heating, you don't want to reset your air, you want to get the minimum ventilation in, you don't want to add more because you're adding extra cooling to the space. I don't think you'll need to enable that here unless the heating system's down, but
So that's not on its own thermostat then?
nope, it's tied to that thermostat.
Tie that thermostat, and that's good, okay.
And that's another thing is you'll need to recognize that some of these offices, you might have a radiant panel that serves multiple spaces. They only have one thermostat. That thermostat is what controls everything. So,
I see. Okay.
And then all the VAVs are out in the hallways for all the rooms.
very good question. I believe that they all are. I didn't look at most of them, but I believe that they all.
Well, generally speaking,
I
if
believe
you
they
take
all
the
are.
thermostat follower, that's where your box is gonna be, in
Yeah.
most cases.
Well,
Exactly.
the access would be probably.
I don't know why that access is there, but I'm pretty sure that they all are in the
Well,
corner.
it's-
Or-
Yes.
Well, most of the time, that's what
Yeah.
that.
So you got a panel off of.
And the valves for these are up in the ceilings, I believe.
Yes.
And the ends there. So,
Okay.
Exactly.
and they're, believe, over at Johnson.
They're Johnson, yep.
Now, they're on a separate pump now, right?
Nope. All tied to the
Yeah,
same
same
pumps down
pump,
there.
Okay,
Excuse me.
Yep.
okay.
All right.
Are those automatically controlled? I mean, is that something, this is it, that's.
Yeah, it's not the old building where you have a thermostat and you have a separate pump. where you can shut the pump off and it's good for the spray?
It does have, yeah, it does have a separate valve though, and so it does give you the ability to control it a little bit differently, you know, if you decide that when it gets really cold outside, just open up the radiant valves, you can add a little bit of logic to do all that, or you can just disable whatever you want to do. It is a separate output, a separate valve, but it is control out that thermostat current. You know, you might want to say when it's in the mid-seasons, you don't use the radiant, only use it when it gets really cold, however you guys want to do it, but that's not.
And by that, just shut the valve.
Yeah. Real quickly, while we're on the stairwells, I just want to go over some of the fan coils in here. If you look here, you do have this is the controller for the fan coil here, and you notice that it does not have an adjustability knob. We've set all of these right around the 72 to 75 degrees for them, so that's where they're currently set at right now. If you need to adjust it, you can take that cover off, unscrew it Allen key, and it is adjustable. It's just not designed for the students to play and tamper with. They are, these right here, they just kind of stand alone and turn on and off. The ones on the upper floors are for cooling. The ones on the bottom floors are for heating. So when it gets too cold or too hot, the fan turns on and blows the hot or the cold air throughout the space. So this one right here will be the cooling, and as we go down to the bottom, it's the one for the heating. So here we're on the west side of the building in the mail cart storage area. So this is where they park their mail cart in at night. And one of the concerns is the hydrogen, as they're charging batteries, hydrogen is released into the air. They just want to make sure that for safety reasons we have some exhaust fans. There's two sensors. One's right here, and the other one's right here. And not at high because hydrogen's lighter than air and it rises up. All that it does is if it gets too much concentration of hydrogen in here, it closes the contact, which gives you an alarm, which then activates the exhaust fan, which is this right here. Real simple. Just the hydrogen sensor, really not much maintenance. The sensors do have a limited lifespan. I can't remember what it is off the top of my head, but it shouldn't be too bad.
Okay, so if we get alarm in the middle of the night or what have you, we'll just come over. If we have to, we'll just open up the door and let it.
Well, and ideally, you should just be able to open up the exhaust or turn the exhaust fan on.
Okay.
And then it should do it all by itself. It's just an alarm
yeah,
contact
yeah.
we're getting that says turn the fan on, so
Okay.
it should be good. This sensor does have a fault, so if it does go in a fault, it will beep. And so if you do get a beeping noise, there might be something wrong with that device.
So then the exhaust fan is up on the roof and up.
It's right here.
Yeah, I see it, but where did you go from there?
You know, it's looking at the access here, right here. I'm assuming that it's probably right here.
The exhaust sensor.
Okay.
It's an
Yeah.
often
Oh, okay.
part family
Yeah.
bathroom.
There you go.
You see your motor right there and your blades and stuff.
Yeah, okay.
That doesn't look like it's on.
The display shuts off to save energy for some reason, but it's, yeah. This one has a little flashy amber light.
Okay.
Yeah, see, there wasn't much communication. But the display does stay off on that one. So. Cool. I guess to follow up, the other air handler downstairs, which is air handler 2, identical layout, everything's the same with it, with the exception of it's got 2 VFDs on it instead of 1. We do control those VFDs in parallel, just like the other ones, so they both ramp up and down together. That one I believe that they have oversped because it is a fan wall, so it doesn't go 0 to 60 hertz. I think it actually goes 0 to 90 hertz. I believe the bouncer sped it up to get the ratings that they needed that bit, but it is a fan wall with 6 individual fans, I believe. But just so you know, it's not limited to 0 to 60 hertz, it's 0 to 90 hertz, I believe. Well, the minimum is still 15 hertz, I believe.
Yeah.
Is there a way to test these to make sure that they are working?
There's a
How does the fan works?
A couple things you can do, and in the O&Ms it'll kind of explain, there's a test button here where you can run the tests where it'll actually give you an alarm, make sure everything like that works. You can actually read what the concentration level is on the sensor as well to see what it is. But other than that, besides calibration, you put a calibration gas, the sniffer to calibrate it that way, but that's really it. There's not much calibration that you need to do. The sensors, I think it's 3 to 5 year lifespan on them, I think is what it is, and the sensors just pop out, pop a new one in.
Okay, not to go back to the stats, but the same thing with those. Calibrated.
All of those thermostats are factory calibrated calibrated at the factory, plus or minus, it's either 0.2 or 0.5, I think it's half a degree, plus or minus. So they are all factory calibrated. We can calibrate them if need be. Generally they don't I haven't really seen an issue with those going out of calibration. These actually sense air through them, whereas the other ones are just like a resistance device. So generally with the thermostats, the issue that you might get as far as calibration might be bad location of the sensor. You have other devices affecting them, current, something maybe behind the wall blowing against it or something like that. They shouldn't go out of calibration is what I'm getting at.
But they
But
can't,
we can
they don't
calibrate
now?
it if need be. So if you're getting an error in a reading doesn't seem feasible to you guys, we can put an offset in there to calibrate those sensors as well.
As far as changing them out, say something with the
All you-
display video.
It's an unserviceable item. Basically what you do is you undo the Allen key up top, pop it off, and replace it with the new one. Yeah. Yeah, real simple. Not really much to service on those. These are just service.
Well, like, what you're not gonna be putting it up and trying to get the air, okay, it's actually blowing off right now.
Yeah, it's not
Yeah,
bad.
that's pneumatic, that's what we used to.
Oh, those are rough.
I know.
I think that's pretty much it as far as a walkthrough of the building that I can think of off the top of my head.
Okay.
Any other questions as far as location sensors, equipment right now?
I think we're good.
Cool.